Now let us take the other case, which is we want to find total number of cases in terms of identical objects. Now first of all, try and understand what do you mean by identical objects. So अभी तक जितना भी we have taken all our distinct objects. So now we are talking about identical objects. So what do you mean by identical objects? So that means you cannot differentiate, right? Differentiation is not possible. So differentiation is not possible among the objects. So this is the meaning of identical objects, or the reciprocal of distinct. So for example, if I say, if you people have seen the billiard table, so billiard table has all red balls, majorly red balls, right? So all of them are identical. You cannot identify sort of that red ball or this red ball because all of them sound same. So that is what is meant by identical. So now let us talk about if how do you select when the items are same. So for example, again we'll go for selection first, right? Selection could be 0 selection, 1 selection, 2, 3, 4, and you can select all of them. So out of n identical items, if you want to select 0, in how many ways you can do so? Only one way. That means you didn't select anything. So that means there is only one way that you can select nothing is don't select, right? In how many ways can you select one item from a pool of n identical items, right? So now people generally here do a mistake that they write NC1 very quickly. So first of all, remember that whenever you are saying NC1, so for n here should be distinct. So obviously this formula is wrong here because here n is not distinct, it is identical. Surprisingly, here also the answer is 1. Answer does not change, answer is still 1. Why? Just imagine there are n identical red balls, right? When I say identical red balls, so that means you cannot write R1, R2, R3, something like this. You can only write this sort of thing when they are distinct. That is why you can say that is R1 ball, that is R2 ball. So now when all the balls are identical, that means you can just write R, 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 and so on, right? And if I tell you that you have to pick one ball out of it, whenever, so understand it that way, that you have a bag. So whenever, and there are n red balls in a bag which are all identical. So whenever you pick a ball, what you will report to me? You will say, sir, red ball. You put that back in the bag, again pick a ball. What do you will report to me? Sir, a red ball. So does your answer change? No, your answer does not change. So for that is why I am saying every time you will just say me, sir, the same red ball. I don't know which one. So 1. Similarly, if I talk about 2 red balls are to be taken from this bag, what you will report? Sir, 2. Every time you will say, sir, I think these are the 2 red balls which are same, right? So you will not be able to distinguish. So again, for 2, for 3, for 4, for n also, all the answers are 1. So if you see, total number of ways of selection in case of identical items becomes what? N. Again wrong. So if n would have been, if I have talked about at least one selection, if I talk about total selection, it will be n plus 1. And if I say at least 1, yes. Now if you tell me at least 1, then yes, the answer would be n, right? So the total number of ways in which a ball can be selected would be n. So here minded, it is written wrong. It should not be. For 0 or more means n plus 1, at least 1. So 0 or more, this is the answer for 0 or more, and this is the answer for at least 1, right? Okay. Now this I have taken when there were only red balls in the bag, right? There could also be green balls. For example, now let's say there are p red balls, right? There are q blue balls, and there are r green balls, right? So, and all these balls are given to be respectively identical, right? They are respectively identical. So in how many ways total selection could be done? So if they are different categories, so what we will do, we'll combine all the formulas. So for if there were p identical balls, the answer would have been what? P plus 1, right? If there were q identical balls, the answer would have been q plus 1. For r, it will be r plus 1. So this is the answer when they are asking total number of ways, right? And if they ask at least 1, that means you have to at least select 1. Just subtract 1 from the answer. This 1 will be when nothing is being selected, right? So p plus 1 actually includes your that answer where p will be included or not be included. Q plus 1 is also including the answer where q can be included, or that means blue ball can be included or not included. R plus 1 means that green ball may be included or not be included, right? And there would definitely be a one case which would say not included, not included, not included, that is the one sequence, and we have to subtract it, right? This is how you should remember this property. So let us apply this in a particular problem. The problem says that a bag contains 3 1 rupee coins, so 3 rupee 1, 4 50 paisa coin, right, rupee 50, and 5 rupees 10 paisa coin, right? This is I can say. Okay, and now you people tell me that whether this is identical or not. All rupee 1 are identical because they have the same value, whether they were printed in 2012, 2013, or let's say in 2016 or 2017. It doesn't matter because you will always tell them that they have the face value of rupees 1. So all rupee 1 are identical, all 50 paisa are identical, or 10 paisa are identical, right? So that means we can say there are 3 categories of identical items. This is 3 times repeated, this is getting 4, and they have 5 in the C category option. How many selections of money can be formed by taking at least one coin from the bag? So you will pick a coin from the bag. You are being asked in how many ways you can do so. As simple as that. And now you people know the answer. This is P, this is Q, this is R, and you have to select at least one coin from the bag. So the answer would be using this particular formula. Remember, we just did it. Very, very simple. So n minus 1 for at least 1. So this becomes what? 3 plus 1, 4 plus 1, right? 5 plus 1 minus 1. So the answer would be nothing but 4 into 5 into 6 minus 1, which is nothing. This gives you what? 120. 120 minus 1. So answer we were looking for is 119. So C is the answer. So this is how you have to grasp this particular problem. Okay, now if we were to take selection in terms of mixed items, so what do you mean by mixed items? So mixed items, if I have to tell you, so mixed item means P alike. They are P items which are of one kind, so for example P red balls. Then they are Q alike, right, Q red balls, and R alike, right, let's say R blue balls. And there are N distinct items also. So in a bag there are various things, let's say P red balls, so for example P red balls, right, Q blue balls, R white balls, and they are N distinct objects. So I don't know what it is. It might not be balls, but they are different items, right? You can say a pencil, for example, it's a pencil, it has a pen, right, a scale, whatever you want to say. There are various things in the bag, but they are N and which all are different. So in how many ways out of this particular bag now you can select items? So very simple again. For P identical item, what was the answer? P plus 1. For Q alike, Q plus 1. For R, R plus 1. For N distinct items, we just did 2 raised to power N, and minus 1 for at least one selection. So this answer is for at least one selection. Right? You got it? I think you people might have now got what I'm talking about.